finds the largest prime factor of any int. Pretty cool. This problem, it's kind of annoying whether or not you feel like doing math because, at least in my opinion, this is stuff that if you did it by hand, it would be pretty easy to figure out with writing. But here we have to figure out how to do it with this int. We got to figure out how to take any int and then do a bunch of stuff to it. So what were like the various parts of this problem? What do we need to figure out how to do?
You need to find the factors first, all the factors of a number.
Yeah. What else do we need to do?
Then you're gonna find the prime numbers of the collection of the factors that you as the result of that number.
Yeah. And then finally,
return the biggest prime factor number.
yeah. Cool. So let's see. Are there functions for factors of or prime, something like is prime? Do we have built-in things in Swift for those, or is that part of the problem that we have to figure out how to count those things? I will answer the question. No. They don't exist. Sorry. Okay. Well, that's okay. How can we figure out if a number is prime? Let's use just plain English. And if you're using the chat, can you just come on the mic instead, please?
If it's divisible by itself and 1.
Yep. There's an important step there, which is it's divisible only by those two things. So it can't be divisible by any other numbers except for 1 and itself. Great. We'll figure out how to do that in a second, but let's also define another term. What is a factor?
Combination of two ints. When you multiply it, it will result of the main number.
Yeah. Great. And then finding the largest, I think we know how to do that. There are many ways. Largest, could use .max on an array. Could definitely do other stuff. Cool. So we are going to have to create the code that does these 3 steps, and hidden in this largest section, we'll need to figure out how we can keep looking through a number to find its largest prime. Does that fit? Yeah, okay, cool. Great. All right. So let me express an opinion here. Opinion. There's something like is prime. I like to extend the type because we're talking about the identity of some var. By that I mean I would rather have a computed property on int. It's an extension int with a computed property is prime, which is a bool that I just return something. That way later on I could do something like var num is equal to 13, return num dot is prime. I just think that's cleaner to use. Y'all can give me 30 seconds. I'm gonna go tell the dog to be quiet. I'll be right back.
Mute.
The dog was barking at people. So let's come back to this. How can I figure out if a number is prime? It's divisible only by 1 in itself. Well, that makes it a little tough because I have to rule out every other number. And how do I rule out every
Start
other?
with the evens.
Say again?
Do you want to start with the evens?
Yeah. So how do we rule out evens?
Mod 2. It wouldn't be 0, equal to 0.
Yeah. So we could say guard self mod 2 equal to 0 else return false. So this guard is just making sure at that step that it is not equal to 0, sorry. And if it is equal to 0, so else, then return false. What else can we do? Let's think about a number like about something like 84. It's not too big, but it's also not a very small number. Do we need to see if it can divide by every number up to 83 to see if it's prime? Or How can we make this a smaller task for ourselves? What are some ideas? Do I need to see, is this divisible by 3? Is it divisible by 4? Divisible by 5? Divisible by 6? All the way to 83? Rod's changed into a crab. Well, looking at 84, something like that, and something like any number larger. The nice thing is, so here's the nice thing. If the square root and any number smaller than it is a factor, chances are something smaller than it is a factor. So, for example, in 84, a factor is 42. But 42 would be multiplied times 2. So we would actually catch this multiplication if we started at 2. And in the same way, another factor is 28. But we would catch that situation because 3 times 28 is 84. So once we checked the number 3, we would already get it. Another combo is 14 times 6. We would catch that at 6. So what numbers do we need to check up until? We're kind of getting closer if you look at it. First, there's a big disparity between the numbers, 42 and 2. Then the numbers got smaller. Then the difference between the numbers got smaller. What values do we need to check up until?
From the square root and down.
Yeah, so we're just going to check from the square root and down, because the pattern that exists here is that there's always, for any large factor, if that's a large factor here, there's always some smaller number it's multiplied by. So even if I wanted to know that 42 is a factor, I would know this number is not prime just by checking 2. The same just by checking 3. I wouldn't need to check that on the other side 3 multiplied by 28 is what gets me 84, because once I see 3 goes in evenly, then I know this is not prime. We're not checking for all of the factors when we're looking for a prime number. We're just going to see and make sure that it doesn't divide in evenly. So we could do something like guard self divided by 3 is not equal to 0, else return false, etc. But how do we make this dynamic so it can work for any number? Instead of just having continuous guard statements, what could we do?
Could you use a for loop?
Yeah, let's use a for loop. So for I in, and Tia said, let's check up to the square root. So I'm actually going to get rid of these guys, because what we're going to do in our for loop is check all the numbers between 2 and the square root. And if any of them divide in evenly to self, then we return false. Otherwise, we'll just return true. So for I in 2 ... and there is a square root here. So there's a built-in global square root function, but it takes a double. The nice thing about ints is that they can cleanly become doubles. Thank you, Foundation, for that. And then we have to convert it back to an int. So let me just do that one more time. Square root takes as an argument a double. So we needed to take self, get the square root of self, but then to make this range work, we needed an int right here. And now for any I in here, just to
I'm
see if
sorry.
this is time. Go ahead.
I'm not understanding why itself.
Because we're actually extending int. So in the end,
Oh,
we want something like this, and we'll just refer to that int as self in this scope. Cool. So in our loop, we're looking through a range here, getting the square root. What do I want to do? What do I want to rule out?
you want to see how I is divisible against the number you are in your range.
Yep. Let's say if self mod I is equal to 0, what do we do? Is that number prime if it divides evenly?
I think so.
So if we look at 84, and I is 2 when we start, if 84 mod 2 is double equal to 0, so if 2 divides in evenly to 84, what do we know about 84?
It's an even number.
Yep. And any even number besides 2 is not prime. And it's the same for any other number. So if this was 87, 2 factors would be 3 and 29. Well, we're going to go to the next iteration of our range, and we'll see that there's a 3 that divides in evenly to this number, 87. And so because any number between 2 and the square root of this number divides in evenly, that means we know that number is not prime. Again, remember, this is just a characteristic. It's just a property of an int that we're looking for. And then, very simply, none of those numbers divide in evenly. What do we know? Phoenix, if none of the numbers divide in evenly, what do we know about this int?
Sorry, what was the question?
Yeah. So here we're just figuring out if it's prime. If none of the numbers that we look through between 2 and the square root of that number, if none of them divide in evenly, what do we know about the number we're looking at?
That's prime.
Yes, sir. So we can just return true. Again, this is just an extension to say, is this number prime that we're looking at? Because we need to figure out if a number is prime. Then we need to look at its factors. And then we need to go ahead and use some max, or maybe just find the largest element. But here we're set up where I can say, like, I want it over here. I can look at any int now and just get back a Boolean value saying if it's prime. Is 13 prime? Let's test it out. Yep. Is 12 prime? Cool, it's not. So if you don't know the term, here all I did was I set up a helper for this problem. I could do all of this inside of a function, but it makes it easier if I just have it elsewhere and I can in one line say number.isPrime. Cool. So now I want to make my largest prime factor function. What does this return?
An int.
I love ints. Amazing, thank you. Great. And I do want to say, so far, our solution works for any programming language. This extension might be a function in other languages, but this way of finding out if something's prime is going to work for pretty much any language that has loops. So a pretty simple 4-line implementation to check if something's prime. Now we got to figure out how to find factors. It's kind of similar to checking if something's prime. How do we find factors? If you're in the chat, sorry, I'm just gonna drop using the chat because it's tough for me to moderate. How do we find factors?
We could use modulo.
Cool.
And just compare. We can we could say if num mod num equals 0. I'm not sure.
Yeah, compare. And how would you explain that, like, just in plain English?
I am not sure exactly what we're comparing the number to, but we would be comparing it to something, and if it's 0, it would be a factor. If the remainder is 0.
Number. If the remainder of dividing by that number is 0, factor. Amazing. I love it so far. So I think we need another loop. What should our loop do?
It should get all the factors.
Get all the factors, cool. And then when we see a factor, what should we do?
Check if it's prime. Use the extension is prime.
If it's not prime, you throw it out. Disregard. What about if it is prime?
We can store an array that we can later sort.
Cool. Sounds good to me so far. So here's a question. What's our loop gonna be? I'm gonna set it up similar to the other one for something in something.
one dot 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 num.
Let me ask you, do we ever care about one? This is kind of just a math question.
No.
Yeah. So one is not a prime number, just by definition. CEDH, I don't know why. So we don't worry about one. Let's start at the next prime number, or the first prime number, I should say, which is going to be 2. So let's go through Eric's process. Check if it's a factor. Rod, how can I evaluate that?
If it's a factor, we could put it in an array.
Yeah, all right. So do we have an array right now?
No,
Okay,
no array. Make the array.
let's do that. So here's an array of ints. I'll keep track of my factors there. Yeah. Go ahead.
So if num mod I equals 0, you can append it to factors. Factors dot append.
Okay. Let's make this a little more descriptive though. Do I want to append, do I want to look at all the prime factors? Or do I want to just, I don't know, look, it's just get the prime factors. Sorry, do I want to look at all the factors? Or is there a specific subset of factors that I want?
You want the prime factors.
Cool. So we need to evaluate something else in here.
Well, you could also evaluate if num mod itself is 0, but is equal to 0, but that's also true for any number.
Yep.
So I'm not sure what Eric had an idea where he had a dictionary and just recorded the number of factors each number had, and if the number was 2 in the dictionary, then we would loop through an array of just those numbers and then find, no, we wouldn't loop through it. We would just we would sort it and then we'd grab the last one, which would be the highest number.
Okay. Let's see. Those sound good, but actually I feel like what you're doing there is you're figuring out if a number is prime.
Oh,
And
yes.
I tried to be helpful, I guess, and just extend.
We already did that.
Yeah. So if I check out num is prime, I get back a bool. So if I want to see if something's prime, how could I evaluate that inside of this if statement?
We can use the is prime. So
let's pass it to Sam. I want to use the is prime. How should I use that?
Yes.
How can I do that?
Can't you use it instead of that if statement?
Well, so this checks if it's a factor, but I also want to check if it's prime.
So inside just another if statement. So if num dot is prime, and then append it.
Cool. And what's a way that we could put, I see an if statement and another if statement. Is there a way we could get both of those checks on one line?
Do it and.
Yeah. Cool. So I've got these numbers. That's great. I'm going through, I'm seeing if they're prime. I'm sorry. I'm seeing if they're prime, and I'm also seeing if that number, that I, is a factor. So I actually want to see if I is prime. So if the number I'm dividing into num to see if it's a factor is also prime, I'll go ahead and add it to prime factors. All right. How do we feel thus far? I love it. What do we do at the end? So we said we would look for the max. Cool. Return the largest of those prime factors.
Prime factors dot max.
Prime factors dot max. I'm going to see a little bit of an error here because this is optional. What should I do if there are no prime factors?
Return false.
Well, we're returning an int. Returning an int. What should I do if there are no prime factors?
Return nil.
So we can't return nil because this isn't optional. But what we can do is, and you'll see this very often, is you can just return 0. So if there's no valid answer, common practice you see, if there's no valid answer, just return 0. All right. Let's try it out. Our num is 12. Just doing some math. The largest prime factor of 12 is 3. Let's see if we get it. Uh-oh. What happened? Does anyone see this error? What does the error say here?
Doesn't like your range.
Yeah. But that's weird because num is 12. Let's print out I at each step. Uh-oh. It looks like it doesn't even make it into that range, right?
Can we switch the online 53? Can we switch them around for I in num ... too?
Yeah. Why do you think that?
Because the error message says can form range with upper bound less than lower bound.
Yeah.
Um,
So let's see what num is and see why it's giving us this issue. Num is 12. That sounds good to me. But here, we start with 2. Let's take a look just one more time. Print. Num is, we'll interpolate num to debug. I is I. Cool. Num is 12. I is 2. Hang on. Is the upper bound less than the lower bound? If a number is only prime if it is greater than 1, I should probably guard against that. So guard self is greater than 1, else return false. Any number 1 or below, sorry. Any number 1 or below, that's right. Make sure it's bigger than 1 because any number 1 or below is by definition not prime. And if the number itself is 1, then that number is not prime. Let's see how it works now. Oh no, why does it still not work? Think about how ranges work. This range starts at 2. This range starts at 2. That means the first time I go to check if this is prime, my range is 2 dot 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 2. That ain't gonna work. So let's do some quick mathy stuff. What I'll also say is guard self is equal to 2. So if it's 2, it's true. Guard self is not equal to 3. 3 is also prime, so we can return true there as well. And here's some fun stuff. Because a guard statement is kind of like saying this, but the opposite. Return true. I can just say, if I've already guarded that self is greater than 1, then for the range between greater than 1 and greater than 3, so 2 and 3, I can just return true. And then the reason I did that is because the square root of 2 and 3 is less than 2. And that's why my range was not working. So this guard statement is guarding for the case that I get a number whose square root is less than 2 and messes up this range I have right here. Let's see. Did that fix it? Yeah. Okay. Let's take a look once more real quick. I made sure number is greater than 1, then at this step, I have numbers between 2 and the highest number I can compute. So now at this step, if I'm guarding that it's greater than 3, that means that any numbers that it gets here, So it can only get 2 or 3. And they're both prime. I can just return that here. Otherwise, the range would be invalid if the square root of my number is less than 2. So we have to go in, we have to fix our computed property. You can use this nice little like inference right here. All right. I run it. It works. That's good. Can anyone think of a way to not take up any space? So if I said, get rid of the prime factors. Here's a helpful hint. Currently, I'm counting from low to high. So I have to keep calculating until I reach the end of the range. So we don't even have to use recursion. I do love recursion. We could definitely use recursion in a variety of ways in this problem. But think about our range. I'm counting from low to high. What if I could look at the range in reversed order? What I can actually do is, let's say, take a range, and once I have that range, so I'm going to put in these parens, look at it backwards. Either of these will work. So we'll iterate starting at the highest number, and we can do the same evaluation, but now we don't need to keep track of that number because we know if we're starting from the highest number, then we can just return I. And if we don't reach a number, we can use this little default we had here, just return 0. So that is a